Okay, so for section B, we're going over transformation of quadratics. Question number 1 asks us to compare the graph of g of x equals x minus 6 squared plus 10 with the graph f of x equals x squared. F of x equals x squared is just the parent function, so what we have to do is compare that to what we are given. So inside of g of x, we have parentheses, and what's nice about this is inside the parentheses in the room, you have your x, okay? So if you're in the room with your x, you do the opposite, okay? So let's go ahead and write that down. Inside the parentheses, you're in a room with your x. So you do the opposite. So what that means is if you have x minus 6 and you look at negative 6 on the number line, you're going to the left, okay? But you're going to do the opposite. So instead of going to the left 6 units to get to negative 6, that minus 6 is telling us we're going to go to the right by 6 units, okay? So negative 6 tells us we're going right 6 units. And then in the outside of those parentheses, we have that plus 10, okay? The plus 10, we're just going to take it as face value, okay? So plus 10 is going to be 10 units up, 10 units up, okay? So this form of the quadratic is called the vertex form. And what's nice about the vertex form is you can easily see your h and your k. Your h and your k is just the x value and the y value of the vertex, okay? So when it comes to the h value, you take the opposite of what you see. So again, negative 6 tells us we're going to the right by 6 units. And whatever you see outside of those parentheses is your k value, and you take it for face value, okay? Okay, let's move on to question number 2. Describe the transformation of g of x equals negative 1 over 4 x minus 4 squared plus 3 from the parent function x squared. Okay, so in this one, we still have the vertex form. This is a, this is h, and this is k. Okay, now the a value is important because it tells us roughly what our overall quadratic function looks like, okay? So here is my a value. If your a value is greater than 1, then we have a stretch. If our a value is in between 0 and 1, then we have a shrink. If your a value is positive, that indicates to us that our parabola is upward facing. And if our a value is negative, it is downward facing. Okay, so now that we know that, let's go ahead and describe the transformation given our a, h, and k. Okay, so our a value is negative 1 over 4. So because it is a negative, it's downward facing. And because 1 over 4 is in between 0 and 1, it is also a shrink. Our h value in this case is equal to 4. Okay, so we look inside the parentheses, we see that there's an x, and we do the opposite of what x is telling us to do. So if you see negative 4, you actually have 4 for your h value. And if you look at the number 4 on the number line, you go 4 units to the right. So 4 units right. And then our k value is outside of the parentheses, and we just take it for face value, okay? So we have 3 units up. If it was minus 3, it would be 3 units down, but because we have plus 3, it's 3 units up. Okay, so go ahead and box your answer. Okay, moving on to question number 3. Transform the parent function f of x equals x squared with a vertical stretch by a factor of 6 and a translation of 2 units to the right followed by 5 units up. Okay, so for each one of these, it's modifying its a, h, and k value in the vertex form, okay? So vertical stretch by a factor of 6 affects the a value. Translation 2 units to the right affects the h value, and 5 units up affects the k value, okay? So the vertex form for the parent function f of x equals x squared is just 1 times x minus 0 squared plus k. Okay, so when it comes to a vertical stretch by a factor of 6, all we have to do is multiply 6 to the a value. In this case, with the parent function, the a value is 1, so 6 times 1 is just 6. And then when we go to the left or right, that means we're going to go ahead and change what's inside the parentheses with that squared. Remember, this is the quadratics unit, so you have to have that squared with the parentheses, or else you would have a line, okay? So we have x minus 0 inside the parentheses for the parent function, but if we want to go 2 units to the right, well, 2 units to the right will give us plus 2, but because we have our x in the room, we're going to do the opposite. So instead of a plus 2, we're going to go minus 2, okay? And then 5 units up tells us that outside of the parentheses, we're just adding 5. So our final answer, we're just going to leave it in vertex form, and I'm going to name it g of x so we don't confuse it with f of x, is g of x is equal to 6 times x minus 2 squared plus 5. Okay, so question number 4, given y is equal to x squared minus 2x plus 2, find the equation when we translate 4 units to the left and 2 units up. Okay, so for this one, again, if you want to go left or right, we affect the inside of the parentheses, and 2 units up is just going to be outside the parentheses. So let's go ahead and write this out. So this is mostly for standard form. So notice we have x squared minus 2x plus 2. We have our a, b, and c values in standard form. So we're going to go ahead and just modify what's inside the parentheses. So the 4 units to the left, if you do that on the number line, you'd hit negative 4. But we're going to do the opposite because you're in the room with your x. So instead of x minus 4, you're doing x plus 4 to go 4 units to the left. Okay, and then 2 units up, we're just going to go ahead and add 2 to our function. Okay, so now we're just going to go ahead and replace wherever we see an x with x plus 4. Okay, so we have x squared, so now we have x plus 4 squared, then we have that minus 2, so just replace the x with x plus 4, so we have now negative 2 times x plus 4, and then we have that plus 2, and then we're adding another plus 2, okay, because we want to go 2 units up. Go ahead and distribute the x plus 4 times x plus 4, and we get x squared plus 8x plus 16, and then if we distribute the negative 2, we get negative 2x minus 8 plus 4, okay? Now, we're going to go ahead and combine like terms, and we get x squared plus 6x plus 12 for our final answer, okay? So that is section B. I highly recommend you look over our notes for 2.1 to see all the different types of transformations that you might encounter for this section if you still need help.